Welcome back. Today we look at one of the more exciting aspects of computer programming, and that is allowing computers to do different things in different circumstances. This is entirely why computers appear to be smart. It seems that they're making decisions. Of course, they're not really making any decisions. The programmer is doing all of the decision making. But we're going to learn today how that works through a number of structures, all called branching structures. And they're really exciting. Let's take a look at a couple of them. We'll begin with the one on your screen. It's a basic form, and you can enter your name in. Tim Berners-Lee, that's the default. And then you can click a button. So let's see, let's presume we are Tim Berners-Lee, and we'll click the button, and it says, hey, thanks for inventing HTML. Awesome. You know who Tim Berners-Lee is? You guessed it. He invented HTML. He's a pretty important guy, but he's not a multi-billionaire, and so he's not as famous as somebody like Steve Jobs. Okay, let's see what happens, though. I'm going to reset it, and then I'm going to put in a different name. I'm going to put in, I don't know, Andy Harris. And then click it, and apparently nothing. Okay, so this program only does something if I've listed my name as Tim Berners-Lee. F5 key or refresh, and it starts out there. Okay, that's pretty cool. Now let's see what's going on. As usual, we look under the hood at the code to see what's happening. The HTML is truly not that exciting. It's simply a label, input, button. We're used to that. And there's a check name function attached to the button. All right, now let's look at the JavaScript code where things are exciting. We have a check name function. And it begins exactly like you'd expect. We're going to have label output. Now, this is a label that we're going to print output in. That makes sense. And a text box for input. So that helps us see here's where we're doing output, here's where we're doing input. I love naming things like that. And then finally, we're going to say username is txtinput.value. So go to the text box and get its value. This is an interesting part of event-driven programming. See, when I create the page, that actually puts the prompt out there, and simply by responding to the button, I'm assuming the user has already put something in there. Okay, that's exciting. Now take a look at line 12. If username is equal to Tim Berners-Lee, hold on, there's a lot of interesting things happening. First of all, we know the keyword if pretty well, right? I mean, we use that in English. I don't know where you are, but right now I'm having a really rough winter here in Indiana. And so I think today the temperature was -5 degrees. So I would say, if the temperature is below 0, stay in the house. That's an if statement, right? If certain condition is true, then I'll do a certain behavior. So if the temperature is below some value, I'm going to say, hey, don't go anywhere. Stay in the house. Make a video or something about game programming. So that is something we're used to in English. Well, the same thing happens in computer programming. A condition is the thing I'm really testing, and in programming it's a little more formal. A condition is an expression that could be evaluated as true or false. My goodness, if you're taking a programming class, I guarantee that would be on a midterm. Okay, so a condition is an expression that can be evaluated as true or false. That's really the key to all decision making in a computer. And most of the time, conditions are comparisons. And this is one of those cases. So username, that's a variable, double equals. Remember before I've told you to read a single equal sign as gets. That's because this is a different meaning. Now in English, we can say equals to mean two different things, but in computer programming, the distinction is important. Here we're talking about assigning. I'm assigning some value to a variable. Here I'm talking about comparing, and it is very different operation. So I'm comparing to say, okay, does this string Tim Berners-Lee equal the value of this variable name, username? And so that is either going to be true or false. Does that make sense? Okay. So if statement, all it does is it sets up, there's going to be a condition. Inside parentheses, you put the condition. Okay? You follow me? Okay, the condition will usually be some kind of comparison. There's a few others we'll use later. But typically a condition is some kind of an equality comparison or a less than, greater than kind of comparison. For strings, normally equality is what we look for. All right, so the condition itself goes in parentheses. It's followed by a squiggle brace. We saw squiggle braces before when we were beginning functions. Well, a squiggle brace means, hey, something interesting is about to happen. The next group of code lines is important. That's true for a function. It's also true for an if statement. So the code or lines of code after the squiggle brace is stuff that you do only if the condition is true. So if the username is equal to this value, Tim Berners-Lee, then it's going to do all the code in here. In this case, printing out, hey, thanks for inventing HTML. Look him up. The dude is awesome. Seriously. Okay, then we have this right squiggle brace. That means I'm done thinking about the condition. I can put as many lines as I want in there, but then I need to use the end if to indicate, all right, I'm done. So that right squiggle brace. Now notice something that's peculiar to my programming habits, but I like to actually label all of my right squiggle braces because they all look the same. And it's really, really easy to get confused when you start to get 10, 11, 15 layers deep, and believe me, we will. It gets confusing to figure out what's what. So there's two tricks I use to keep track of my code. First of all, I tend to label all of my ending operations, my right squiggle braces. The other thing is I'm extremely careful about indentation. And so if you indent 2 spaces every time you're in a new structure, then you have a pretty good clue about what's going on in your logic. If you're finished code and you're not back out to the left-hand margin, well, you've probably forgotten something. So you can look and see if they all line up to understand what's missing. All right, so does this make sense? Yeah, what's happening here is we're waiting for the button to be clicked, and when the button is clicked, we go get the value of that text box, and then if that value is equal to Tim Berners-Lee, then we do some code. We say, thanks for inventing HTML. Now, this is a very limited form of the if statement. All it does is, well, it does something if a condition is true. That's still extremely powerful. So far, you with me? Okay, let me show you a variation. Now, this one looks almost the same. It says, please enter your name. It still has Tim Berners-Lee, and if we click it with the default, it says, thanks for inventing HTML. But what happens if I enter over the name of some other web programming luminary, like, I don't know, Andy Harris? We click there, and no, it doesn't know who that guy is. He's probably not that important. Okay, so this is interesting because in the last example, if I was anything but Tim Berners-Lee, nothing happened. It just sat there and pouted. But this time it does one thing if the condition is true, thanks for inventing the internet, and something different if the condition is false. Once again, we'll look at the code to see what it does. Most of it's the same. The HTML is the same, the check name is the same function, but the if statement is slightly different. We still have the same condition, and we still do the same thing if the condition is true, but now we have on line 14 this else clause. Else is really interesting because it only lives in the context of an if. I kind of like doing it with the little moose antler thing going on, the squiggle braces on either side, because that helps me see, okay, else is part of that if structure, and it's beginning a new structure. Here's what happens. If the condition is true, everything between the if and the else is executed, so this line would happen. If the condition is false, everything between else and end if would happen. And right now I only have one line in there, but again, I could have as many as I want. So this is really powerful. This is like the branching of a train track. I mean, I can go one direction or the other, and it's all based on the position of the train switch. Well, a condition is the little train switch. That's what tells us, hey, do this code or do that code. So anytime you see a computer appearing to make a decision, it's doing something very similar to this. Does that make sense? You ready for another variation you'll see sometimes? Okay, let me show you another variation. Okay, so this is an if else if. So first I enter in Tim Berners-Lee, and it says, thanks for inventing HTML. And then I can add another name. Let's say, I don't know, Andy Harris. Oh, sorry about that. I don't know what I did there. Please enter your name. Let's take a look at the other things that it can do. Oh, yeah, I know another guy we could do. Let's enter in Al Gore. Thanks for inventing the internet. Okay, awesome. So it recognizes the contributions that Al Gore made. He actually was pretty helpful, to tell you the honest truth. I mean, he did some of the best things a politician could do. He wasn't really an inventor, but he was. We make fun of Al, but he was actually pretty helpful. All right, so wait a minute. This one's a little bit different. It can do one thing if you are Tim Berners-Lee, and something else if you're Al Gore, and if you're somebody inconsequential, it does a third thing. Okay, so this one seems a little more complex, but it isn't too bad. Let's take a look at it and see what it does. It's almost the same. Again, the HTML is the same. The function is the same. We set everything up the same way, but now we have a more complex type of if statement that has multiple conditions. Okay, here's the basic one. If username is equal to Tim Berners-Lee. Marvelous. So that we've already seen. Say thanks for inventing HTML. Now here's a variation of else. This is else if, meaning, okay, that's not true. Let's try something else. What if username is Al Gore? Then it prints out something else. Thanks for inventing the internet. I got more. What if the username is How Come William Lee? Ah, he's the guy that invented CSS. Are you taking notes? These are important people. Okay, and then there's finally one more else saying, okay, if none of these, I give up. If it's none of these, this is what I do. You can have as many else-if clauses as you wish, but each one needs a completely new condition. So I can't say else if Al Gore, else if How Come William Lee. I have to say else if username is equal to Al Gore, else if username is equal to How Come, and so on. Does that make sense? Now, it's not necessary to put an else clause when you use else-ifs, but it's generally a good idea because even if you think you know all of the possible things the user could enter, well, if you think that, you don't know users. The minute I think I know what a user is going to do, I'm wrong. So I always try to put an else clause to catch what else could go wrong, even if I don't think there could be any other value. So you can check multiple values with this if-else-if structure. And that can be extremely powerful. Does that make sense? Okay, I'll show you a couple of other examples you'll see once in a while. Here's this idea called a nested if. Now this is interesting because it's using some numeric comparisons that are slightly different. Check temperature. Well, today, here the temperature is 6 degrees below zero. Are you kidding me? It's freezing. No, it's colder than that. Okay, but let's try it again. Let's think happy thoughts. Let's say it's 85 degrees. It's warm. Okay, cool. Let's try another one. Let's try like 110 degrees. I'm using Fahrenheit. Okay, it's really hot. Okay, so this is pretty powerful because it seems to be able to handle a much wider range of choices. And there's a couple of interesting things happening here. Essentially, what you can see is I've got an if statement with a condition. Now, in addition to the equality check, you can also use some other comparisons. You can do less than, greater than, less than and equal to, which is just a less than followed by an equal. Greater than or equal to, which is greater than followed by an equal. Not equal, that's an exclamation point and an equal sign. I've got all those listed in the book if you're using the companion book. They're pretty straightforward. You'll see them as we go. Okay, so that's all fine. So if temp is less than 60, then here's what's interesting. We do another comparison inside the first. Oh, okay. Sure, if the temperature is less than 60, now we say, okay, that was cold, but is it less than 32? Okay, so we have another if that only happens if the first condition was true. So now we have a condition inside a condition. Can we do that? Well, yes, we can. Okay, and we'll say it's freezing. Now, if this condition is not true, we know at this point that the temperature is higher than 32 but lower than 60. So we'll just call it cold. Now, this else clause is related to that if. You see why lining things up is really important? We know in all these cases we're over 60. So now let's find out how much over 60. If it's less than 75, it's between 60 and 75, we'll say it's cool. If it's not, well, let's do another check. Is it higher than 90, or is it between 75 and 90? So you can use this complex set of nested if statements to get very complicated behavior. Now here's something I'm going to warn. A lot of programming teachers will teach you how to use a thing called Boolean operators, and, or, and not, inside your conditions to get more complex behavior. Boolean operators are wonderful. I love Boolean operators. I love Boolean algebra. But here's the deal. It's kind of complicated, and it probably doesn't work exactly the way you think it does. So here's my general rule for my students. I say you are absolutely welcome to use Boolean operators in your conditions, things like and, or, and not, if you can explain to me De Morgan's law. That's well, if you don't know what it is, you have no business using these. The moment that you can explain De Morgan's law, I'm going to say you know enough about Boolean logic to comfortably use and, or, and not inside your conditions. You will see a few places I'll use them where it's relatively straightforward and obvious, but for the most part, I recommend beginners stay away from and, or, and not conditions. You can almost always get the same behavior with nested ifs and with else ifs, and it's going to be a lot easier to keep track. I can't tell you how many times students have come to me with absolutely messed up logic with a bunch of and, or, and nots, and I say, get rid of every and, or, and not, and everything's fine. So don't even get in the habit. Let's just try to do this more often, and you'll be okay. You all right? Okay, one more structure I want to show you briefly, although I'm not a big fan of it, and that is it's called a switch statement. So let's try some more. Let's try Bill Gates. Thanks for MS Bob. Okay, we'll try another one. Steve Jobs. The Newton is awesome. Do you remember either of these things? Probably not. Okay. Let's put somebody else in there. I don't know. Ringo Starr. Do I know you? All right. So this uses another structure called the switch statement. Now, the switch statement came from C and C++, and it's powerful, but I'm actually not a big fan of it. And I'll explain why in a moment. But first, here's how it works. Of course, we're asking the name. And then switch allows us to say, I am thinking about the variable name. And then the case says, all right, if name is equal to Bill Gates, this is what I want you to do. If the name is equal to Steve Jobs, this is what I want you to do, and so on. Now, there's a couple of reasons that I actually don't like this. The first reason is that it's very tempting to do sort of, you could always use an if-else if. And so that's fine. One problem here is that this only works with equality. We can't use inequalities here. You can't say if temperature is less than something. You can only do an equality. The other thing I don't like is this thing, this break. It's non-standard. What the break means is I'm done. If you don't put the break line in, it comes down here to the next case. Even if that's not true, it counts it as true. Yuck. I don't like the formatting. It's not really standard even with the C syntax. I think it's non-standard. And I'm very much not a fan of the break statement. The break statement says, hey, I give up. I don't know how to write code correctly. I want you to jump out of this structure. I don't like the break anywhere else. I really don't like that it's required by switch. I'm still showing you this because you will see it in other examples, but I rarely use a switch in my own coding. Many languages now don't even allow it. So I'm not a huge fan of it. If, else, if is usually clearer and does the job. The default clause of a switch is just like the final else. It does everything. Okay, so you get this. So what's important? Really important to understand conditions. It's also important to understand the if and the else if. If you get nested ifs, fine. If not, that's going to come with practice. Don't worry too much about switches, but know they're there in case you need them. Sound like fun? Yeah, we're going to have to practice some of this and put it all in place to build our own game that can make decisions, yes? All right. Well, come back next time, and we'll talk about loops. That's even more exciting. All right, I'll see you then.